Bluetooth for high-end. Can we use Bluetooth for high-end equipment and high-end audio streaming? Actually, at the beginning, Bluetooth concept was enable short-range cable-free communication between electronic devices using low-power radio waves to create personal area networks. It allows devices like phones, headphones, keyboards and speakers to exchange data without physical network infrastructure, operating on principle of master-slave connections with small networks called piconets. And there is nothing about high-end audio. And when I tested Bluetooth technology some 3 years ago, it was really not ready. But today there are new technologies, new codecs, new principles, and maybe we are. But Bluetooth is rapidly developing technology, and I think today we are pretty close to high-end capability transmit through our devices. And there is one critical topic to be answered. Do we need 24-bit audio, or it's okay with the 16-bit audio when we're talking about a high-end audio performance? And here is one research where real tests with real audience has been done comparing 24-bit audio versus 16-bit audio. And here is Rational Audiophile website where those tests has been published. And let's quickly look to some things like demographics. There was audience selected and that methodology used. And you can see that male are pretty dominant comparing to the female, and it's the same with my family, that I'm doing all the hardware stuff and my wife just enjoys case by case with the high quality music, but I'm the key guy. There was an age, so definitely we can say that age is from 20 to 60, with the dominance of the mature male. Also, they were asked the question, are you a musician? Are you a professional musician who knows how instruments really sound? And also, do you do any audio recording, editing and mixing? So there were also audience with experience of editing and mixing music. Some questions about the hardware. And you can see that those audiophiles are people who really enjoy high fidelity audio. Their spendings, majority of spendings were between 1,000 and 3,000 now for their equipment. Of course, there were some of them has really exclusive equipment and some of others has basic equipment. But in modern world, it's not that important, because for reasonable price you can get really high quality audio equipment capable to perform on the top level. Also, there were questions about asking, do they know some tool, FUBAR 2000 ABX utility to allow instant AB sampling capability. Some of them were familiar, the majority not, but this was used in that experiment. And then they gave some music samples and asked audience to find out which one is which, and then some number did it wrong and some number did it right for different songs. And if you look at results, and then you can see that kind of 50-50, 50-50, 50-50, and you can see those 50-50 answers everywhere. So normally it doesn't matter, either you have musical background, you are engineer or whatever you are, the musicians the same, failing everywhere. So typically 50-50. And if you look at this picture, musicians accurately identifying 24-bit audio. So we are selecting guys who dealing with music in everyday life as professionals. And below 50. Below 50. So more answers were wrong or not right. So those statistics clearly show that 16-bit CD quality is enough for absolute high-end. We are not able to distinguish at the final mastered piece of music. We are not able to distinguish between 24-bit audio and 16-bit audio. regarding engineers, it's also really new technology, and also I would say it's not convincing. Some 54% was able to correctly identify. It's still in frame of statistics. Even most experienced guys are not able to do that. Hardware reviewers, they failed totally. Very expensive gear people failed totally. Headphone users, the same. So 50-50. So not able to distinguish. And age, this is in frame of statistics. So everyone failed in that experiment. And as you have seen in that test or in that research, there's a clear answer that human is not able to hear between 16-bit and 24-bit audio for the same studio mastering. And here I want to emphasize for the same studio mastering, because for high-end audio and for 24-bit audio, often at the mastering level, we are setting higher dynamic range than for a normal audio, because we have high fidelity, high resolution equipment, and then we master it different. And this is where that some people confidence came that 24-bit audio is better. It's a very important conclusion what comes out, because if the 16-bit that CD quality is okay, that Bluetooth has solved high-end audio transmission capability. One more thing to be on the same page, the Nyquist theorem, this digital audio, some basic principle, also known as the Nyquist-Shannon sampling theory, states that to accurately capture and reconstruct signal, it must be sampled at a rate at least twice the frequency of its highest component. This minimum sampling rate is called the Nyquist rate. And what does it mean? When we are talking about audio, we are talking about the highest threshold of our hearing of 20 kilohertz. That means with 40 kilohertz sampling, we should be able 100% recover original signal. Sometimes in marketing, some companies showing this picture, 16 bits versus 24 bits audio, and showing preferences of 24-bit audio. It's not correct, because there's nothing about the bits, it's about the sampling rate. Bits is by far more about the noise threshold, not about capability to recover your audio signal. To recover your audio signal, you need that right sampling frequency. Why do we have 16-bit DSP, 24-bit DSP, and even 32-bit DSP? When our audio has been mastered, done all changes, and it's ready for export, then we record it in 16-bit dynamic range depths, and it's perfectly fine, because there is no mistakes, there is no errors, all signals are at a 0 dB set, and we have some special compression for super high peaks, etc, etc. This studio signal is ready, and then at 16 bits we can get maximum listening performance. Why do we need 24 bits for recording and maybe higher quantization level? This is for mistakes. For example, you put your microphone, your dynamic microphone for your music, and record it at a lower level than you think it will be. And you have plenty of headroom. You can raise the volume and you have all data in. You have some headroom for mistakes. And also, if you recorded in a higher level, for example, someone did a normal speech and then it screams and then you go back, then this screaming is still in frame of quantization. If you have a 16-bit equipment, when it screams here, then it's the hard clipping and you are in trouble. Here we can have a headroom for mistakes. And also when we do some digital processing, also everything is here. And when we master at 16 bits, we have a perfect audio. Why we need 32-bit DSP? When we do heavy signal processing and there are mathematical errors, then we have some headroom for that 24 bits dynamic range. And if we some errors here, those are far below that Thetan standard what we need for another equipment. Those bit depths are for professional use, when you really do a lot of changes with your audio signal, and then at the end you get a perfect 16-bit signal. Here you're adding a number of errors, but those are far below that final result what you want to have. And here is dynamic range for 16 bits. It's 96 decibels. For 24 bits, those are 144 decibels, and for 32 bits, those are 192 decibels. The most dynamic music has about 70 decibels dynamic range, so CD quality exceeding that requirements for that music already. One more terminology what we should use, they are PCM, pulse code modulation. File contains raw and compressed digital audio data, while WAV or waveform audiophile format files is a container format that includes this PCM data along with a header providing metadata like sampling rates and bit depths. Essentially, WAV is a type of PCM file with added information, making it widely used standard format for high quality lossless audio. Actually, this is CD format. Yeah, this is CD format, standardized, accepted, and doesn't matter either you use the PCM or a WAV terminology. Those are the same quality. In WAV format, you have some service signals added that your electronics understand what is coming in. One more terminology, audio lossless compression. Audio lossless compression reduces file size without any loss of data, following for perfect reconstruction of the original audio, whereas lossy compression discharges some audio data such as imperceivable frequencies to achieve much smaller file sizes, but at the cost of some sound quality. Lossless formats like FLAC are ideal for archiving and professional use due to the high fidelity, while lossy formats like MP3 are better for general listening, streaming, and situations where file size is a major concern. What we can take from those definitions? It is possible to compress CD without data losses. We can 100% get back the data what we had. And this is really important. FLAC offers a lossless compression ratio, typically reducing an audio file size by 30 to 70%. And this is important. It's not like you can compress it 10 times. And with average of around 50 to 60% for common CD quality audio. This ratio varies depending on specific audio content, with simpler sounds compressing more effectively. That means for some boom tsic tsic or our country music, we can compress it more. For symphonic music, we compress it less. And this FLAC provides various compression levels that trades increased processing time for smaller file sizes without sacrificing any original audio data. Here we are not losing audio quality. What we are losing, we are investing in compression time, in delay. And there are some more things to know. The CD quality has a fixed bitrate of 1.4 megabits, yeah? Or 1411 kilobits per second. It works with 16-bit depth and 44 kilohertz sampling rate. Remember Nyquist principle that we need a double sampling frequency comparing to highest frequency what we have in our signal. In music signal it's 20 kilohertz. There's even some headroom. And following conclusion is that for lossless audio transmission we need about 700 kilobits per second. No, some specific music maybe more, but majority, I would say 90% of music is okay with 700 kilobits per second. That's half. One more important note. Audio format transcoding is a process of converting an audio file from one format to another, such as from WAV to MP3. This is often done to improve compatibility with the different devices, optimize storage space, or to prepare files for online streaming or video production workflows. The process involves decoding the original audio file into an uncompressed format and then re-encoding into the desired target format. This is important to remember because all quality losses comes from transcoding. This transcoding is a really bad thing, and when we look how to get a high-end or high fidelity audio through the Bluetooth, this is critical item to understand. I'm renting Spotify services, and they use even one more codec. It's close to MP3 actually, but it's kind of better, and I describe it as Lossy codecs. And a little bit about those Lossy codecs like MP3, AAC, Spotify codec. Actually, they use the same principle, different processing, but the same principle. Now, first, there are certain threshold what human can't hear. There's still sound, but for us it's absolute silence. Our dog is laughing to us, but we don't hear anything. So we can take away those components what are there. And the second is masking. When you have one really loud note, like a flute or something, they masking certain area what we can't hear, and this masking principle is second. Here we're really taking away components, throwing them away. Yeah, this is where the losses happens, because we are not transmitting those components. And here is a little bit different picture for the same. There is a big bump, and those small clink clink are not audible. And there's the same picture as before, but just a schematic. Here is a large note, a large sound, and then this area is masked, and we are taking away those data from our stream. And there is capabilities how we can compress different music, and you can see in a FLAC for 3.5 minute song, it's about 83 megabits. Apple lossless, more advanced algorithm 40 megabits, and then Lossy, you can see almost 10 times we can compress comparing to FLAC. That means almost 20 times to original signal. And MP3 320 kilobits per second. When we are compressing one time from CD, we are getting about 95 or even 98% of music fidelity, and normally we can't hear a difference. There's many people who are swearing that they can hear, but there was also blind tests, and we are not hearing that. That means one times compressed signal is close to high end as well. And here is non-compressed audio signal. Yeah, here is the frequency. There's all details, original audio CD, and when we compress, you can see that above 16 we have really limited information. We are not 100% cutting it out like a filter. If there really something what presents with a clearly audible level, yeah, we will leave it. But you can see how many gaps do we have. And here on a mid-range, of course, this is pretty saturated, and you can't see a difference. And then at the low frequencies, maybe some more gaps, because our sensitivity is low, and here we keep everything. So this is lossy content. And as I mentioned, for a Spotify we're using OGG Vorbis Jesus format, and if you pay for subscription, I get 320 kilobits per second quality, and me and my internal reptile is saying that it's good quality, but I don't want to go below that. And there are different codecs, as I mentioned certain time ago, 3 years ago, when I did the first tests with a Bluetooth. I was not happy and left it on a shelf. But today we will do some tests, and maybe there are good messages for a high-end audio lovers to use it. So this is a standard codec for or compatible with all Bluetooth devices, and by audio it can deliver a -97 dB noise level. It's a CD quality, dynamic range CD quality, total harmonic distortions absolutely acceptable. This is studio quality requirements for today, and intermodulation noise also quite okay. With AAC, for me it's hard to comment this intermodulation noise, why it's kind of bad here. You can go this addictedaudio.com and read it, but generally the same. Standard aptX. This is a Qualcomm algorithm for a standard definition Audio, the same CD quality, very good, total harmonic distortions, no kind of intermodulating and noise, probably some noise is there. And aptX HD, it's above CD quality, all around, it's perfect all around for me, for CD quality. And if you define that high-end is a CD quality that we are there with aptX HD, and then it's more advanced kind of for HD audio transmission, LDAC quality, it's Sony proprietary codec. It's kind of crazy good, but there is a compatibility issues. And for me, I define it that aptX HD is okay for me, due to the better compatibility and non-proprietary codecs. Because when you have some proprietary codecs with a limited adoption, that always makes small problems, because then there are less money to support that codec, and earlier or later either they go or they become some niche players or others. But I would say aptX HD for me is a good news. And you can see here is a maximum bitrates what they can provide, and LDAC can provide any CD quality and maybe some even 24-bit music as well if you're really addicted to them. But there's no reason to go for that music. But it could be for professional usage or for some wireless microphone recordings or for other stuff. But who knows? And aptX HD can do above 500. That means for 90% of music they can do lossless. Maybe there are some very specific super saturated complex musics or symphonic musics that could be a bit difficult, but normally I would say 98% of music will be transmitted without any damage. And here is one good site, SoundHub, also who summarized different type of Bluetooth codecs. For music listening, latency is not a problem, but for video and music it's a problem, because you are losing lip sync and you should deal with that. It's annoying when you are watching a video and audio is not in sync with the lips moving. And regarding music, Bluetooth technology developers decided that everything is fine with the quality, and next generation development will go on those low latency codecs that you can use wireless technology for home theaters and different type of video and audio applications, like with your phone, Bluetooth receiver and headphones. For example, you can watch TV in a pub and follow some sports competition and make some drinks and other stuff, and then multiple respondents can listen it, and then also it's a good application, and it's kind of a wireless future that everyone can listen some things in a crowded area. Almost the same for airports and for other things. So this is where next technology development investments will go. And the second, your quality largely depends on what kind of digital to analog hardware you are using. And here I picked a mainstream device, China developed SMSL device based on reference designs which are provided by chip manufacturers using good chips, and you can have incredible parameter there, exceeding CD quality several times. So if you have a good hardware, then you have a crazy good device. And this is 250, 300 euros device, kind of end game. Of course, we can discuss how good is a volume regulator and other stuff, but electronically using those latest chips, crazy good. Yeah. And there are measurements, everything is so good. And you can see there are so many manufacturers using the same chip, the same architecture, the same patterns, and they are getting the same results out of it, and the price range is different, but there's nothing to talk about the quality, exceeding everything. And final thought, so good, yeah, for that price, and this blah blah. How about a really budget device? This is budget device, but a good one, I would say. You have this Qualcomm module. It is produced by original Qualcomm, and you can buy it for reasonable money. And then there is PCM 5102 audio decoding digital analog converter. This small board, it supports all possible standards up to aptX HD, and for me this is fine. Broad voltage supply. You can feed it from 6 to 20 volts, or you can feed it through the USB input. Small board, high performance, and let's check what that digital analog converter is capable of. PCM 5102, and it is capable of 112 decibel signal to noise. Dynamic range is the same. So we need 96 dynamic range for CD quality, and this chip is already capable for 16 decibels more. How about the total harmonic distortions? Minus 93 decibels. Here I put that value in a calculator. Yeah, that's factor so many zeros. So this small chip already exceeds all our requirements so many times. And let's now do some basic measurements of some units. I bought a set of units from AliExpress, from Amazon, from eBay, and we will compare different type of solutions and how they are implemented, and are there some solutions what we can use for high-end audio, but really for a budget price.